Let's look at Sn1 conditions now. Okay, so predict which compound or condition in the pairs below will result in a faster reaction. So the faster reaction we're looking at now is for Sn1 kind of condition. So for Sn1 reactions, you want to be able to create a carbocation. Okay, that's the main thing because it's a two-step process. So in the first step, you create the carbocation, so the leaving group goes away, and in the second step the nucleophile will come in. Now the first step that occurs in Sn1 reaction where the leaving group is going away is really the rate determining step. Okay, it's the slowest step, so that's the important step. What kind of a leaving group you have, that is generally not so important because the rate of the equation, okay, is given by just the substrate. Okay, the nucleophile is nowhere, okay, as far as the rate of the reaction is concerned. So which means that you should not consider the leaving group as part of controlling the rate in Sn1 reaction. But in any case, let's go ahead and start with the first one that we have to compare. And in the first case, what we have is chloride as a leaving group. And I just said, okay, that the leaving group is not so important over here. So long it's a weak base, that's good enough, okay, for a leaving group. So here it's chloride in both cases, which is fantastic. So we don't have to compare that. The only thing we have to compare now is that we have a secondary halide in the first one, and we have a primary halide in the next one, okay. And so because we need to create a carbocation, because that's the first step, so in this case, let's see in both cases, if you form a carbocation, this is what it would look like. And in the first, in the second one, it would look like this. Okay, so which means that the first compound will give you a secondary carbocation and the next one will give you a primary carbocation. A secondary carbocation is more stable than a primary carbocation, so which means that the first compound here will give you a more favorable product, okay, which means you will probably get more yield. Okay, that's what it really means. Okay, let's look at the next one here. And in case of the next one, again, we have bromine as leaving group, which means, okay, fine, we don't have to compare the leaving group. So which means we need to look at the nature of the carbon, okay, and the carbon that's going to form the carbocation from the leaving group going away. So in the first compound, bromocyclohexane, it's going to be a secondary halide, a secondary carbocation. And in the other one, it's going to be a tertiary carbocation, okay, after the bromine leaves. Okay, so the tertiary carbocation is going to be more stable, okay, than the secondary carbocation. All right, so tertiary more stable than secondary carbocation. So which means that the second compound here is going to give you more favorable products, or the reaction is going to go faster, your yield is going to be more, everything will be better, okay, with the tertiary halide. So that is for the second set of compounds we have to compare. Let's look at the last one. Last one, we have the same substrates, okay, so which means we have a secondary halide here and we have a secondary halide in the next one too. It's exactly the same compounds. So what we are comparing here is, of course, the nucleophile now. Okay, so to compare the nucleophile now, you need to have a good nucleophile, okay, in order to have a good reaction. Okay, but the thing about our Sn1 reaction is right here what I wrote on the top, okay, which is that the rate of the reaction is really given by K and substrate. So which means substrate is the only one that is involved in the transition state. Okay, so which means when you draw your reaction curve out, this is it. Okay, so the first transition state that you form here has just got the substrate in it. Okay, so which means that the nucleophile is not really involved. Now you can have a better nucleophile, that's a different thing, but nucleophile is not part of the rate equation. Okay, so which means that both of the reaction will work the same way, okay, because in both cases it doesn't really matter if you have a strong nucleophile or a weak nucleophile, it is not part of the rate, okay, of the reaction. It's not part of the mechanism initially, okay, for the rate determining step. So both of them will work at the same kind of rate.